Okay. For large samples, difference in means. Okay. How do we do it? If suppose x1 and x2 are the means of the samples with be the two independent large samples with sizes n1 and n2 drawn from population with mean mu1 and mu2 respectively, and standard deviation sigma 1 and sigma 2. How does the formula vary is it's the difference between the means of the samples by under root of sum of the variances. Okay. It is like that. The Z statistic is defined like this. What we are testing for is whether the two populations are equal or not is what we are testing for. Okay. Procedure is same. I'll be setting H naught here. Let mu1 and mu2 be the means of the two populations. I don't need them in the formula. Now, what's been given to me is, I'll just write the data. N1 is given to me as 1000. N2 is given to me as 2000. Okay. X1 bar is also given to me. X1 bar is given to me as 67.5. X2 bar is given to me as a 68. Sigma, standard deviation from the same population standard deviation is being given to me as 2.5. Okay, I know the formula when it is standard deviation of the population. I know the formula when it is the standard deviations of the samples. Okay, first thing is I should set H naught. Okay, what is H naught? Mu1 is equal to mu2. Or in other words, samples have been drawn from same population. Samples have been drawn. That's why their means are equal. Have been drawn from same population. Okay. Of course, I can write with standard deviation 2.5. Right? H1 would be what? Anything I can take. Okay. Again, looking at the means of the samples also, I can decide first sample mean is less than second sample mean. So I can go with left tail depending on the, okay. Now what I'll do, simply bluntly, I'll just take a two-tail test. Okay. Mu1 not equal to mu2, I will write here two-tail test because if I write here only, then I'll be able to decide alpha also. Alpha is equal to 0.05. Since I've taken it to be two-tail, this will be 0.025 Z alpha by 2 with a negative sign. This will be Z alpha by 2 with a positive sign. Right? So once this is done, I'll look at sample sizes. N1 and N2, both N1 and N2, both are greater than 30. So I'll go with the Z. Z test statistic. Test. Okay, so it would be what? Z is equal to x1 bar minus x2 bar by under root of sigma squared. There's nothing like sigma 1 because both are from the same sample plus sigma square by n2. This would be what? 67.5 minus 68 by under root of course, sigma I can take it out, whole square of sigma, if it taken out of the root, it is sigma only 2.5, 1 by 1000 plus 1 by 2000. I'll calculate this value using a calculator. This would be my Z-cal. Two-tail na, I should be little cautious. Z value, of course, I know it is 1.645 on the right and minus 1.645 on the left. So this value turns out to be minus 5.16. You can clearly see it should be a left tail test because first mean is less than the second mean. Okay. Yeah. Minus 5.16. Now what is Z-cal? Z-cal is minus 5.26. What's Z tab for alpha by 2? I have taken correctly only. Yeah? At a 0.5 level of significance, Z alpha by 2 for 0.5. I should have it, right? Two-tail test, 1.96. Two-tail test, it is 1.96. Right? I'm sorry. This is not 1.96. This value is. Okay, so Z tab value is what? Is equal to 1.96. Now this value is what? Less than or greater than? There are two values. What that is less than minus 1.96 is rejection region. Greater than 1.96 is also rejection region. Now, less than 1.96, it is in minus 5.16 is less than. Z cal is less than minus 1.96, right? Hence, we reject H0. Hence, we reject H0 and accept H1. That's it. Okay. Yeah. At 5%, reject H0 at 5% LOS, level of significance, and accept H1. What that is what is H1 saying? Both are not drawn from the same population. That is, both samples are not drawn from same population. Drawn from same population with standard deviation 2.5, with SD 2.5. That's what I will conclude. This is how I will do difference in means problem. Okay. Any tail you can take, either the left tail or two tail. Okay. There's no problem. Thank you.